This video is designed to answer what the function is a zero. Seems like every time in class we get to start talking about zeros and there's like 2 minutes left and we have no idea what in the function Mr. Fick is talking about. So here it is. In this situation, we've already figured out what the axis of symmetry is, what the vertex is, and even the y-intercept, and they've all been graphed. Next, we need to figure out the x-intercepts. We know that finding the zeros has something to do with the x-intercepts. We don't really understand why suddenly start talking about zeros and miraculously the x-intercepts show up. Why is that? Well, here's what it means. If you look at your y-axis, this thing right here, and you start at the top where it's about 10, and you start going down. When you hit the x-axis down here, anywhere on this x-axis line, what's your y value? Your y value is 0. And since your y value is 0, anytime your function crosses that x-axis, your function value has to be 0. What does that mean? It means this whole thing equals 0 when it crosses that x-axis. Now, we don't really know in this situation exactly where it's going to cross. We know that it's going to cross somewhere around here and somewhere around here. So when we say solve to find the zeros of the function, what we're really doing is we were saying that the whole function equals 0, and that if we can figure out what value of x makes this true, that makes this whole function actually be 0, then that x value must be the point that the graph crosses the x-axis. This is where factoring comes in. Factoring allows us to solve this equation for the values of x that make the function 0. Hence, the zeros lead to the x-intercepts. Now, we have something called the zero product rule, which means if we can factor something or rewrite this polynomial as a product of two factors, we can then solve for the value of x that makes any of the factors 0, and we'll have one of the x values. Here's what I mean. Try factoring this trinomial. If you do that, you're going to get 0 equals x here, x here. We're going to have a 4 and a 2. And since we've got a negative sign for our c factor, our c, you're going to have a plus and a minus sign. And since the middle term is the positive, you're going to want the plus sign on the bigger number, and you're going to want the negative sign on the smaller one. This is factored correctly. But how do we go from the factorization to actually figuring out our x values? We're trying to solve it. So if I look at this factor, if I can figure out what value of x makes this thing 0, then I know it's a solution. Because if you plug in something that makes this 0, 0 times anything is 0. So I'm going to try to solve this for 0. Now, many of you might recognize right away the answer is 2. But if you're not sure, or this factor is more complex, you set the whole thing equal to 0 and solve for x. Plus 2, plus 2, and suddenly you have x equals 2. Now that works for the first factor. You can do the same exact process for the second one. X plus 4 equals 0. Solve for x. And x equals -4. This means that our x-intercepts are 2 and -4. So I'm going to go over to the graph, and where it's 2, that's right here, I know that's an intercept. And where it's negative 4, it's going to be an intercept. So 1, 2, 3, 4, right here. And it's going to keep going up forever. Now, how do I write that? Well, x-intercepts are really points. Every point on a graph has two things. It's got an x and a y. Let's start with the x's. We just figured them out. One of them is 2. The other one is negative 4. But, and this should be very consistent, think about what your y values have to be. We just said the y had to be 0. We just solved it so that the y was 0. So your x-intercepts will always have a y-coordinate of 0. And thus the mystery of zeros is solved.